Hi geometry students, this video is a continuation of our triangle congruence notes. So this is the packet we had from class, triangle congruence notes, section 3.2. So please make sure you have it out. That's where you're going to be taking your notes. I'm going to start on the second page actually. Then we're going to come back to the first page at the end. So in class, we had done problem number 1. We're going to look at problem number 3 next. It's similar to problem number 1, where you're trying to prove two triangles are congruent by a specific method. So it's telling us the method for the first one, SAS, and we're trying to say what's the third congruence statement, what's the other piece of information where we would need in order to use this method. Okay, so we're trying to prove PWT, triangle PWT is congruent to triangle SVR. So I'm just going to kind of highlight those two, so you can visualize it. Those are my two triangles. And SAS means side angle side. So it means I need an angle with the sides on either side of that angle. So if my angle's right here, and right here, and I have one side, then I need the side that is the other side forming the angle. So that would be this one, and in my second triangle, this one. And so what does that mean? What two segments must be congruent? From T to W and from R to V. So let's say segment TW is congruent to segment RV. And that's side angle side. So now, like reset, now we're doing angle side angle. So the idea there would be I have an angle and then I have a side. So if I want one more angle on the other side of the side, it would be down here and up here. Right? So I'm just going to kind of put a little mark on those two. So it's that angle and that angle that we would need for angle side angle, because then we have angle side angle. So the side is in between the two angles. And that would be, for my congruence statement, if I want to use like the whole, I have to use 3 letters to name these angles. So this angle would be TPW. And I would say that TPW is congruent to RSV. Okay. Before moving on, I want you all to try problem number 2. On your own. So pause the video, try problem number 2, then press play. Now I'm going to move on to the bottom part of this page, problem number 4. It says, using the tick marks for each pair of triangles, name the method SSS, SAS, or ASA, if any, that will prove the triangles to be congruent. So I'm looking at the picture, I'm trying to identify which pieces do I know are congruent, and then what follows is which of these 3 methods can be applied. So in the first one, I see I have sides, then an angle, then another pair of sides, right? And the angle is in between the two sides. So that would be side, angle, side. Over here, the only information I have is about these angles, right? And if I don't have any sides, this looks like angle, 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 but that's not a method to show congruence, so I would say none. What's going on over here is I have side, side, angle, right? The angle is not in between the two sides. So the issue there is that's the situation that also doesn't work. So this would also be none. And then the last one, there's 2 overlapping triangles, ABD and AEC. So the idea is, if we kind of are looking, we see like CE, we have a side here that's congruent to a side here. And then I also have an angle congruent to an angle, and then an angle congruent to an angle. So I have, if you kind of can visualize. It's hard, this one's harder to visualize because they're overlapping. I have angle, side, angle. And that is one of my methods, so that checks out. We could show these are congruent. So if you flip to the next page, I'd like you to try to do this. Number 5 is the same exact process. You can kind of ignore the fact that it says number 4. So I want you to try this one. So there are 6 different pictures. So for each picture, we're doing the process that I just demonstrated, where you're deciding SSS, SAS, or ASA, and if it's none of them, you would just write none. So once you're done with that, you can press play again, and I will continue with the video notes. The last thing I'm going to go over in these notes is the very first page. At the bottom, I have one new property to introduce to you, and it's called the reflexive property. It's pretty obvious. You're going to think, why is this even a property? But it says that an angle or a segment is always congruent to itself. And this becomes useful when we have a situation like in this picture where we're trying to prove that ABD, that's like the left half triangle, and CBD, the right half triangle, are congruent. And one of the key pieces that we're going to use is the reflexive property, because we see they have a side in the middle that they both share. And since that's congruent to itself, we know that that side in each triangle is congruent. So we're going to actually set up a whole 2-column proof here, and I'm going to walk you through it. So I'm going to have statements and reasons. My space is a little bit awkward, so I actually am starting right at the edge of my page. So I'm going to start by writing my givens as my statements. So my first given is, and actually I'm going to pause for a sec. Before we get started, one good thing with these proofs is always to kind of like read the information, look at the picture, and mark up the picture based on the information. So like if I see AD is congruent to CD, let me just put some marks. There's AD, and now I know it's congruent to CD. B is the midpoint of AC, right? So if B is that midpoint, I'm also thinking already that AB must be congruent to BC, right? So I'm definitely going to talk about that in a minute. And then I know BD is congruent to itself, so I'm already thinking about side, 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 right? So before I even begin, I've already kind of identified what method I could use here. And now I just have to kind of lay out each part line by line. So I'm going to start with my givens. AD is congruent to CD. And my reason is given. Then I have my second given, B is the midpoint of AC. And in the past, I've kind of written 2 givens as one step, but I'm going to be precise here and actually write out my second given as its own step, and I'll show you at the end, you'll see why I'm doing that. So now I want to say, what else do I know is congruent? Well, based on the midpoint, I know that AB is congruent to BC. So what's my reason? Well, I just said it's because I know B is the midpoint, so it's by definition of midpoint. And now I just need to get my one last side that is equal. So I say BD is congruent to BD itself. And like we need to say that because we're using BD as a side in both triangles. So we're showing that those sides are congruent because they're the same. And what property is that? It's the reflexive property. That's this new property that we just learned. So now the idea is I have just stated that I have one set of sides and then another set of sides and then a third set of sides all congruent. So now I know that triangle ABD is congruent to triangle CBD by side, side, side. Okay? And I'm just going to do one more thing in my reason, which is to be really specific about where I showed the three sides pairs being congruent. So I showed that one pair was congruent at step 1, so I'm going to write a little number 1. Then I showed another pair was congruent at step 3, I'm going to write the number 3. And then my last set was step 4, so I'm going to write the number 4. And this just provides someone reading your proof with even more information about how you know it's side, side, side. I know it's side, side, side because step 1, step 3, and step 4 showed 3 pairs of congruent angles. Okay, so that concludes our video notes for today. You're going to be practicing proofs in class, and you'll be able to ask questions when I return on Wednesday.